I'm Anil Kumar. Welcome to my series on providing solutions to questions from previous test papers of Cambridge International Examination. In this video, we'll take up examples related to trigonometric functions. In case you have any doubts or questions, you can always send me an email on the address given here. I'll be more than happy to provide you with suggestions. Here is a very interesting question which had been there in a couple of years back. The question here is, the function f is defined by f of x equals to 3 tan half x minus 2 for x greater than equal to minus pi by 2 and x is less than equal to pi by 2. Three parts of this question are: solve the equation fx plus 4 equals to 0, find the expression for f inverse and domain of f inverse, sketch the function f and its inverse. All right. You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the very first part, which is f of x plus 4 equal to 0. So we are given f of x as equal to 3 times tan of half x minus 2, and we need to find solution in the domain when x is between minus pi by 2 to pi by 2. So let's try to understand this domain itself. Now colored pens and inks I'm only using for explanation part, right? In the test you have to provide solution in black ink. So when we say minus pi by 2, that means in this direction, and when we say plus pi by 2 means in this. So we need to find solution in quadrant 1 or in quadrant 4, correct? That is the idea for x, correct? Okay. Now let's analyze it further. Equation to be solved is f of x plus 4 equals to 0, right? So we are given f of x plus 4 equals to 0. That means we have to add here 4, correct? So that is 3 times tan of half of x minus 2. So if I add 4 to this, I should be getting 0. That's the whole idea, right? So let's try to solve it. Taking numbers to this side, this is plus 2. We get minus 2 equals to 3 times tan of half x, correct? Or we get minus 2 over 3 equals to tan of half x. Now it is kind of important to understand that we are given this domain for x, but here we have half x, right? So that means what? Half of x should be within what interval? We'll multiply both by half, so we have minus pi by 4 to plus pi by 4. Is that clear, right? So we are looking for a solution which is for half x. Let's call this as theta within this interval. Within this interval, correct? That is clear, right? Half of x. That is what we're looking for. So what we will now do is we can say that tan theta, so we are writing theta instead of half x, is equal to minus 2 over 3, right? So minus 2 over 3 means we are looking for solution in quadrant 4, correct? So we can find alpha and then we know the negative value, right? So let's do it. So we get theta as equal to tan inverse of minus 2 over 3, right? You could do this. You may or may not get the exact answer. Sometimes it may give you quadrant in quadrant 2, right? So let's see what we get. So we get shift tan inverse negative 2 divided by 3 within brackets and gives you minus 33.69. That's fair enough. So we get this negative value minus, which is less than 45, correct? So that is what you get. But we need to write answer in radians, right? So I need to convert my calculator to radians. So we'll shift mode and change this to radians, which is 4. And now we'll again find this answer, which is shift tan inverse minus 2 divided by 3 bracket close equals 2. So now we get answer which is minus 0.5880. Now this is in radians, correct? Minus 0.5880, that is angle theta. However, in our question it was tan of half x, correct? So theta for us is half x. So we can write this as half of x is equal to minus 0.5880. So x is equal to minus 0.5880 times 2. So we'll multiply this by 2 now. So it gives you as equal to minus 1.176. Correct. So this answer of minus 1.176, if we round to one decimal place, we get this approximately as minus 1.2 radians, correct? So that becomes the solution to the given question, rounded to one decimal place, right? Rounded to one decimal place. So that is how we can do part 1. And now let's look into part B, which is find the expression for F inverse and domain of F inverse, correct? Okay. So we can actually tackle domain first. We have the function f of x as equal to 3 tan half x minus 2, right? We are given domain of this function. The domain is that x is between minus pi by 2 to plus pi by 2, correct? Now, this is the domain. So to find the range, we know tan is always an increasing function, right? So important thing here to note is that tan theta, or you can say tan half x in this case, is an increasing function, right? It is always increasing. That is a property of tan, right? Increasing function. So that means these limits will give us the minimum and the maximum value, correct? So we can find the value for the function at minus pi by 2. So minus pi by 2 will give us 3 times tan of, we get here minus. So if I substitute pi by 2, I get pi by 4 here, correct? Minus 2. Tan pi by 4, as you know, is 1. Minus pi by 4 is minus 1. So we get minus 3 minus 2. That gives you minus 5. And the value of the function at pi by 2 is going to be 3 tan pi by 4. So when you substitute pi by 2, divide by 2 is there. So in that case, we get plus 1. So we get 3 minus 2, which is 1, correct? So that is the range of this function. So we can say range of f of x is that y value is between these two limits, which is minus 5 and 1, correct? So from here, we know domain of f inverse, right? Therefore, domain of f inverse is basically y belongs to real numbers, where, I mean, domain is x, right? Sorry. X belongs to real number, where x is between minus 5 to 1. Clear? Because domain and range swaps, correct? So the reason is domain of f inverse is range of f of x. Clear? So that's very important thing which you should remember, and that gives you the solution for one of our parts, which is this. Now, let's also find the expression for f inverse, right? So let's do that. So finding f inverse means we just swap this and rewrite our equation. So we could write for inverse, we'll swap x and y, correct? So once you do that, we get x equals to 3 times tan of y by 2 minus 2, correct? So we need to isolate y now, so which gives us x plus 2 divided by 3 is equal to tan of y by 2, right? So we can write it on this side. Tan inverse, let's write this here. Tan inverse of x plus 2 over 3 is y by 2. And now we can write here y equals to, so we get y equals to 2 times tan inverse of x plus 2 over 3, or f inverse of x is basically 2 times tan inverse of x plus 2 over 3. Clear? So that is how we can get the inverse of this particular function. Clear? Okay, so now the third part is to sketch the function f and its inverse. Okay, so we've done 2 parts. Now, to sketch this function, I would like you to pause the video, sketch it, and then look into my suggestions. We have already found 2 points here, right? So we'll find one more. What is f of 0? So let's say f of 0 is what? So when substituting 0 here, we get 3 tan 0, which is 0. F of 0 is minus 2, right? So I'll just make a small sketch here to show you the sketch, but I'll prefer that you do it on a better graph paper, okay? So whenever we are trying to find the graph of inverse, we could actually sketch the graph of the function, and then we could reflect it on the line y equals to x. Is that clear to you, right? Okay, so we'll begin with the graph of the function itself, which is tan, right? So and we have this domain from minus pi by 2 to plus pi by 2 for the given function. So we know this point at minus pi by 2, the point is minus 5. So one of the coordinates are minus pi by 2. So what does minus pi by 2 means, or pi by 2 means? So shift pi divided by 2 basically in numbers is 1.57, right? So we have a point here which is, let me write down minus. Let me shift this page a bit. So we have x value of minus pi by 2. So let's say we take this value as minus pi by 2, right? So when I say minus pi by 2, it is 1.5. So let us say if this is 1 and this is minus 1, this is minus 2, somewhere there in between, correct? That's what we mean. So minus pi by 2, the value of the function is minus 5. So let's use this point as minus 5, correct? At 0 it is minus 2, so let's say at 0 it is minus 2, somewhere here, okay? And then we know at pi by 2 it is 1. So pi by 2 we have a value which is, let's say, 1, kind of here, okay? So that means we could actually draw a tangent curve which is kind of like this. Right, so that's the shape of the tangent curve. I've just squeezed in this portion since we didn't want to go so much down. So that becomes f of x for us. Is that clear to you? Right. Now, let's sketch f inverse. So this point, which is at minus 2, 0, will now be at 0 minus 2. So on the inverse, this point will be right there, correct? Well, the diagram here is not at all to the scale, but we'll go with the points. Now this point on f of x is at minus pi by 2 minus 5. So on the inverse, it will be on minus 5 minus pi by 2. So let's say, let's say this point here is minus 5 minus pi by 2. Is it okay? We're just assuming this to be that point, correct? So this will be the reflection of that on this line, right? And then we have minus 2, 0 as the other point on our inverse function. And this point here is at pi by 2, 1, right? So this is at pi by 2, 1. So this will be reflected and become 1 pi by 2. So at 1, we expect the value of pi by 2, right? So let's say this point is 1 pi by 2. Is that clear? So joining these points, we get our inverse function, okay? So the inverse function, let me just push this, will be, so we are maintaining the shape of the graph, which will be kind of like this, correct? So that will be the inverse function. So when you make to the scale, this will be y equals to x will be line of symmetry between these two. Is that clear to you, right? So take care while drawing these curves. However, the points are absolutely correct. They should help you to get the exact graph. The question here is, prove the identity 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta equals to 2 over sin theta. Part B is, hence solve the equation 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta is 3 over cos theta, right? In this case, theta is between 0 to 360 degrees. So let's first prove the identity. We are given 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta, right? So that is our left hand side. So let's begin with the left hand side and show that this is equal to 2 over sin theta. So we can take a common denominator here, which is sin theta times 1 plus cos theta. Cross multiply, so we get 1 plus cos theta whole square plus sin square theta. Now we can open this and we get 1 plus 2 cos theta plus cos square theta, and here we have sin square theta. Denominator don't expand, never expand, I should say. Whenever you're proving identities, try to keep it as such. Now let's take it to the right side and solve further. You know sin square theta plus cos square theta is 1, right? So we'll do that. So we can write this as equal to 1 plus 2 cos theta. Cos square theta plus sin square theta is 1, so we get 1 over sin theta times 1 plus cos theta, correct? 1 plus 1 is 2, so we get 2 plus 2 cos theta over sin theta times 1 plus cos theta. Now we can take 2 common, so we get 1 plus cos theta. In the numerator, we already have this term in the denominator, right? So you can cancel these terms and you get 2 over sin theta, which is the right hand side, correct? So that is how you could prove this identity. So we have done part 1, which is proving this identity. Now we'll use this information to solve the given equation. So the left side is 2 over sin theta, correct? So let's take it on the fresh page and solve. So now we need to solve the equation, which is 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta equals to 3 over cos theta. We just proved that the left side is basically equal to 2 over sin theta, right? So we know this is 2 over sin theta, which was from part A. equals to 3 over cos theta, correct? Now you can cross multiply. So basically the numbers you can bring together, so you get 2 over 3 equals to sine theta over cos theta, or you can say 2 over 3 is equal to tan theta, correct? Now that should help you to find the answer. We're looking for solutions where theta is between 0 to 360 degrees, right? So in 0 to 360 degrees, tan is positive in these quadrants, right? So we can find the angle alpha and then add 180 degrees to get the other solution, correct? So we can say that we are looking for tan alpha equals to 2 over 3, alpha equals to tan inverse of 2 over 3, correct? So let's put this in degrees and find shift tan inverse 2 divided by 3 is equal to 33.69. Okay, so you can round this to 33.7. So we get alpha as 33.7 degrees. So that is one angle. The other angle will be this, correct? 180 plus. So theta is basically equal to 33.7 degrees and 180 plus 33.7. So let's add 180 to this. Plus 180 is equal to, which is 213.7 degrees, correct? So we have two answers, 33.7 degrees and 213.7 degrees. So that becomes the solution for the given equation, correct? So what you notice normally in such questions, especially from Cambridge International Examination, whenever they have two parts, they are always related, and you can always use what you have done in part A in part B to get your solution. So I hope that helps. Express the equation cotangent theta minus 2 tan theta equals to sine 2 theta in the form of A cos to the power of 4 theta plus B cos square theta plus C equals to 0, where A, B and C are constants to be determined. Hence solve cotangent theta minus 2 tan theta equals to sine 2 theta for theta being between 90 and 180 degrees. You can always pause the video, answer the question and then look into my suggestions. So let's begin with the given equation, which is cot theta minus 2 tan theta equals to sine 2 theta. Since we have to show it in terms of cosine, we'll bring all the terms to the left side, convert them into sine and cosine. So we could write this as cotangent theta minus 2 tan theta equals to, let's say, minus sine 2 theta equals to 0. Writing as cos over sine for cotangent, we get cos theta over sine theta minus 2 times sine theta over cos theta minus sine 2 theta can be written as 2 sine theta cos theta, correct? Now multiplying every term by sine theta cos theta, we get cos square theta minus 2 sine square theta minus, so we'll multiply this by sine theta cos theta, we get 2 sine square theta cos square theta equals to 0. Now we'll write sine square theta as 1 minus cos square theta. So we get cos square theta minus 2 times 1 minus cos square theta minus 2 times 1 minus cos square theta times, we could have taken 2 cos square theta also common, so we could have got 1 minus cos square theta anyway. So now we'll bring 2 times this times cos square theta equals to 0. Now if you open the bracket, you get cos square theta minus 2 plus 2 cos square theta, again minus 2 cos square theta, and minus minus becomes plus 2 cos to the power of 4 theta equals to 0. Now we can combine all these terms and write what we need. So the term in to the power of 4 is 2 cos to the power of 4 theta. Cos square theta, we have plus 2 cos square theta minus 2 cos square theta, which cancels. So we have one of the terms, we get plus cos square theta. As far as the constants are concerned, we have minus 2 equals to 0. So that is the equation which we get. So in our case, we have A equals to 2, B equals to 1, and C equals to minus 2. Okay. Now we have this equation. From here we'll do part 2. So we've done this. Now we'll take up part 2 in the next page. Now let's try to solve this equation. Cotangent theta minus 2 tan theta equals to sine 2 theta. We've just shown that this could be written in terms of cosine. So we'll write that equation and then continue. So this is written as 2 cos to the power of 4 theta plus cos square theta minus 2 equals to 0. Correct? Now to solve this, it is a quadratic equation in cos square. So we can write that cos square theta is equal to, we can apply the quadratic formula, which is minus 1 plus minus b square, which is 1, minus 4ac. So 4 times 2 times minus 2 divided by 2 times a, which is 4. So that becomes equal to minus 1 plus minus square root of, this is 1 plus 16 over 4, or can be written as minus 1 plus minus square root of 17 over 4. Correct? So we get two values of cos theta from here. So cos theta is equal to plus or minus square root of all this. Minus 1 plus minus square root of 17 over 4 whole square, right? Now let's calculate this value. So we have minus 1 minus 17, right? So that is more than 4. So one of the values is not possible, right? So what you notice here is, see, we have minus 1. If I do minus square root of 17, and then if I divide by 4, I get a value in decimals which is more than 1, correct? More than 1. So that is not possible. Therefore, the one with this negative is not possible, right? Only one with positive is possible, correct? Since that is greater than 1, right? Cos theta is between 0 to 1, correct? So that's kind of important to understand. Let's use the calculator to find this answer. It should be in degrees, so we'll just set up in degrees. And what we're trying to figure out is square root of, let me write within brackets, minus 1 plus square root 17, bracket close, divide by 4 equals to 0.8836. So we get this as plus minus 0.8836. Now within 90 to 180, the solutions which we are looking for, theta is between 90 and 180, right? So that means we are looking in quadrant 2. So in quadrant 2, cos is negative. So that means we could get value for cos theta equals to minus of 0.8836, right? Since in quadrant 2, cos is only negative, correct? So we have only one possible value. So we can find the acute angle alpha first, right? Let's find the acute angle alpha. So we get cos alpha equals to 0.8836. So alpha is cos inverse of 0.8836. So we have shift cos inverse of our answer. That gives us 27.91. Now, theta basically will be this angle, correct? Theta. So that means the theta should be equals to 180 degrees minus 27.9. So we'll do 180 minus 27.9. That gives us in decimals 152.1. So that is our answer, right? So we get the solution. There's only one solution to this, and which is 152.1 degrees. So I hope the steps are absolutely clear. So at this stage, you know that cos theta basically is between -1 to +1, and therefore there is only one possible value. The negative is not valid, right? So we took the positive value. Now here again, since we are given the domain of theta between 90 and 180 degrees, we expect negative answer only. So positive is not valid. So we solved only for the negative one and got our solution. Is that clear to you, right? Here is question number 5 from one of previous papers of 2017. Let us see how to solve this kind of question. Express 2 cosine theta plus square root of 5 sine theta in terms of r cos theta minus alpha, where r is greater than 0 and alpha is between 0 to 90 degrees. Giving the value of alpha correct to 2 decimal places. Now this is a very standard question and is asked in many test papers. Let us try to understand the strategy. So what we are given here is 2 cosine theta plus square root of 5 sine theta. Now we need to write as one particular function, which is cos theta minus alpha. So the formula, if you work backwards, think like this. So thinking portion, let me show you in a different ink so that you understand the strategy which we are going to adopt. So if you look into this particular right side, we are saying we want to make it equal to r of cos theta minus alpha, right? That is r of, if we expand this, we get cos theta cos alpha plus sine theta sine alpha, correct? So r outside, right? So we are looking for the values of cos alpha and sine alpha. So if you compare this, then 2 and square root 5 can give you some idea. So what we normally do is we find the value of r as, we find this value of r as equal to magnitude of these two, right? Which is square root of 2 square plus square root 5 square. So what we get here is 2 square is 4, square root 5 square is 5, and what we get here is square root of 9 equals to 3. So we get the value of r as 3. Now, if I take 3 common in our equation, then what happens? See, if I take 3 common, then I could write this as 2 over 3 of cos theta plus square root 5 over 3 of sine theta. Does make sense to you, right? So that really shows that cos alpha and sine alpha could have a value 2 over 3 and square root 5 over 3. Perfect. So from here you can correlate that r is equal to 3. That is the value of r. And now let's work on cos alpha. So we are looking for cos alpha equals to 2 over 3 and sine alpha as equals to square root of 5 over 3. To get the value of alpha, we'll divide one by the other. That is to say, sine alpha by cos alpha is equal to what? Is tan alpha, right? Which is tan alpha will be equal to square root of 5 over 3 divided by 2 over 3. So that is square root 5 over 3, right? So we get alpha as tan inverse of square root 5 over 2, correct? So that is how we can get the value of alpha, right? Now look here. So on this side, we could write this as, it's better to write this as cos theta, cos of alpha, where alpha is 2 over 3, plus we'll write sine theta, sine of alpha, and that could be written as 3 times cos of theta minus alpha, right? So we got what we really needed. Here we can now compare and we can write what alpha is. So alpha is tan inverse of square root 5 over 2. So shift tan inverse square root 5 divide by 2 is equal to, so that is equals to 48.189, which can be approximately as 48.2 degrees. Okay. So now we have to find alpha correct to 2 decimal places. So 2 decimal places. So we'll write this as 48.19 degrees. Correct. So that is how we'll do it, right? So we got our answer, which is r is equal to 3 and alpha is equal to 48.19 degrees. Clear? So that is how we'll solve it. Now to this question, we have part 2, which is hence solve the equation 2 cos theta plus square root 5 sin theta equals to 1 within the interval 0 to 360 degrees, right? So we just found that 2 cos of theta plus square root of 5 sin theta, we want to show it equal to 1, but we know the left hand side is basically equal to 3 times cos of theta minus, we'll write to 2 decimal places alpha value, which is 48.19, correct, equals to 1, correct. So here let me write down the answer clearly as 3 times cos of theta minus 48.19 degrees. Clear? Okay. Now, as far as cos theta is concerned, within the interval 0 to 360 degrees, cos is 1 at theta equals to 0 and 360 degrees, right? So, but well, here we have, let me rewrite this. So we have cos of theta minus 48.19 equals to 1 over 3. So we will have cosine as positive in 2 quadrants, right? So we have 2 solutions. Let's find alpha, and then we'll get this alpha. This is minus alpha, correct? Or we'll go like this. So this will be 360 minus alpha. Minus alpha, correct? So these are the 2 solutions which we are looking for. So let's figure out. We have shift cos inverse of 1 divided by 3. So that gives us 70.528. So we get 2 possible answers. So we get theta minus 48.19 as 2 values. One of them is 70.528, right? The other one will be 360 minus this, right? So other one will be 360 minus our answer, which is 70.528. So we get 289.471. Correct. So these are the 2 values which are for, we can say, theta minus 48.19. Clear? So that means we have theta value as equal to, we can write theta as equal to two answers, 70.528 plus 48.19, or we have 289.47 plus 48.19, right? So let's add this up. So you can add this to 48.19. You get one answer as 337. Now this answer, they're not specified, so we'll just go for one decimal place, degrees, and the other one is 528 plus 48.19, which is equal to 118.72. So which is equals to 118.7. Right. So we'll just keep it to one decimal. We can write two decimal places also, right? So that is how we are going to answer this particular question. Correct? The other one, it is, let's rewrite this, 289.47 plus 48.19 to two decimal places, 337.66, right? So we'll write this as 67 degrees. Correct? So these are the two answers. So we have our answer that theta is equals to 118.72 degrees or 337.67 degrees. Correct? So I hope these steps are absolutely clear. This is called the wave equation. So I'll provide you with links on wave equation. Plus in this video, we'll also add some other videos based on trigonometry, which have been asked in Cambridge International Examination earlier. Hope that helps. Feel free to write a comment, share your views, and if you have any doubts, you can always send email to the address given here. Thanks for your time and all the best.